This is a demonstration video using a Forrest bandsaw to cut a material called PET, or PET foam. I'll start with the machine, then I'll discuss the material, then I'll make some cuts. The machine I have to work with today is our Model 236 Heavy vertical blade traveling table bandsaw. The 236 is a high-speed machine. We're running a blade speed of about 3,000 feet per minute. The blades run on 14-inch diameter wheels, and this allows me to run almost all 3/4-inch blades and some 1-inch blades. The traveling table, of course, in this case we're running what we call a heavy style table, which means basically rail mounted. So the saw itself, what we call the saw head, so all of this part, on a 236 Heavy, I don't have a lot of room where I can change the dimensions of this machine. In this case, I did make the machine taller. Basically, I just added a few inches of steel here. That wasn't all that difficult. The customer needed this machine just a little taller. I did it for him, but I don't really have the ability to stretch it this way as far as the saw head. So on a 236 or 236 Heavy, the head geometry is pretty much fixed. We have two table versions on the 236. The standard table on a 236 is what I call a cantilever style table. It works a lot like a desk drawer slide. It's very easy to work around, lightweight. The limitation is I can only make the cantilever style table so big before it gets to be unwieldy. For example, if I had a cantilever style table comparable to a desk drawer slide and it pulled out 10 feet, I'd be able to set one nickel on the end of that table and it would capsize the whole machine. So the cantilever style table is one set of dimensions and that's it. If a customer needs a table to handle a heavy workpiece or just a large workpiece, then we switch up to this rail mounted table design. I call it the heavy. It can just be large and light. So switch out the desk drawer slide mechanism for a rail mounted table. Lets me make it as big as I want. So the table on this machine, on the 236 Heavy, is built basically to order. Whatever your application is, we figure out how big a table you need, we build it. The downside is these rails are just kind of awkward. When you travel the table, these rails are still here to bang your knees into or back a fork truck into. Yes, it happens. But it does mean I have the flexibility. This particular machine has some other nice features. This has our pneumatic blade tensioning system mounted on the back side where you can't see it. I've got to tension the blade, I'm using an air cylinder. Controlling it, I've got an air pressure regulator and a manual control valve. Makes it very easy, just about automatic, to set the blade tension. To tension or detension, you just flip a switch. You know you're always getting the correct blade tension in terms of PSI on the blade. Just a very nice, slick way to do it. It's one of these things, once you've had it, you won't give it up. The machine also has an upgrade on the controls. The blade drive motor in this is a 2 horsepower, 3-phase brake motor, standard for this machine. The cabinet is an upgrade. Standard controls are just a magnetic motor starter with overload, push a button, start, stop. The upgrade here is a control cabinet. Cabinet has a fuse disconnect, control voltage transformer, a little bit of basic control logic here. We run a green beacon for saw running status. I can control the machine here, on, off. I also, on this machine, have start and stop buttons mounted here at the jaw operator's position, so it can control from either place. This machine is equipped with a laser guideline light. I push the on button, and let's see if you'll be able to see it. I get a red line, should be able to see that. Shows where the blade is going to pass through the workpiece. Makes it very easy to set up a cut. So you have a mark on a workpiece where you're trying to do a minimum material loss cleanup cut. Turn on the laser, put your workpiece on the table, move it around until you see the red line where you want to cut. Make your cut. I don't need it right now, so leave it off. So that's the saw in short. If you have more questions, please feel free to call us or email us, or I've got other videos on similar machines. The material I'm cutting today is something new to me. This is called a PET or PET foam. It's pretty light. I'm guessing like 1.5 pounds per cubic foot, 2 max, pretty light. It's surprisingly rigid for what it is. It's got a little more resiliency in it. The thing about this that really gets my attention is doing the research on this. This can be used as a thermoforming material. So you can heat this up, drape it over a form or press it over a form and change the shape. It'll hold the shape. That implies it has a low softening point and probably also a low melting point. Materials with low melting points can be hard to cut on a bandsaw. So the blade I'm using here is a 3/4 inch wide, 3/2 inch hook tooth style blade. So it's cutting out a channel of material, making dust. That is all creating friction. Friction makes heat, and heat potentially warms up the workpiece or the blade enough to soften the material, melt the material, and have the blade stick to the workpiece. I've actually had this happen. The worst material I've ever cut is a polypropylene type material. It has a very low melting point, softening point. And I've had it happen there where the polypropylene material melts or softens, the melted material grabs the blade and stops it. It's actually stalled the blade. Or in one case where I was using a horizontal saw, the blade was running horizontally making a cut, the material melted, grabbed the blade, and the moving blade grabbed the workpiece and whoop, threw it across the room. No one was hurt, so it was funny. So I have this sample piece of material. I made a few cuts on it. This is the factory surface here. Well, that's actually my cut. This looks like a factory surface here. It's pretty smooth. I don't know how this was cut before I received it, but that, hopefully you can make that out. That is a nasty edge, and it does show some signs in here, see the camera will focus, of having melted when it was cut. So again, concerning. I've made some cuts already on this. I used a fine tooth blade. I used a 3/4 inch wide, 10 tooth per inch blade. Really a little too fine for this, and proved it was very much too fine. I was having a hard time getting a straight cut. This material is harder to cut than you would guess from its density and just looking at it. So I've jumped up here to a 3/4 inch, 3 tooth per inch blade. I'm gonna try cutting it with this. Let's do this. Oh, I left the laser on. Okay, laser's on, you can see where I'm gonna cut. A note about position the workpiece. The ideal way to use a bandsaw like this is to load the workpiece onto the table and come over here and grab what I call the grocery cart handle. Push the table and make the cut. Do a nice guard here, keep you from just reaching in and grabbing the blade, which, duh. If necessary for service or for some specialty cut, you can unbolt this and take it off. I'd rather you leave the guard on the table. So how do you keep the workpiece from sliding around? This stuff's pretty low friction. How do you keep it from sliding around? I use magnets. Table surface is 12 gauge steel with a 2-inch square tube framework underneath it. To keep the workpiece from sliding around, I use magnets. This is a typical welding magnet. They're all over our shop because obviously we're welding up machinery here. So they come like this, they come bigger, and they stick great to the table. So what I've done here is I've set up a couple magnets on the back side to position the workpiece where I want it. One here to keep it from sliding back. That'll hold the workpiece static on the table while I make the cut instead of having it slide around. We offer also workpiece positioning fences to do the same type of thing, but in a much fancier way. I have other videos on that, or again, you can call and talk to us about it. So let's see how well this cuts with a 3/4 inch wide, 3 tooth per inch blade. Sounds right. What do we have here? I should have been running a dust collection system. This stuff makes all the dust. That's a good looking cut. You know, back the table up, watch how the blade tracks what I just cut. Looks good. A little bit of wiggle on the workpiece, but that's not the blade's problem. So here's my cut edge. No melting. Straight. Consistent cut. Okay. This is good. So what I'm gonna do now, so I'm only cutting through like 8-10 inches here of material. What I'm gonna do now, I'm gonna do now what I just told you not to do. I'm gonna make a bunch of cuts and stack this taller and taller and taller and see how it works when I'm cutting through several inches of the stuff. This is gonna be very much a case of do as I say, not as I do. I wanna knock out some cuts real quick here. Maybe I can do this. This might fly. Yeah. I'm gonna need to raise my guide post for what I'm about to do. A feature of the saw, adjustable upper guide position. So the machine has bandsaw blade guides. There's one right underneath the table, there's one here. The height of this guide is adjustable on this post. So I release the locking screw, crank this up. I'm gonna try to go kind of high here, so I'm gonna do this. Lock it back down. The idea is to keep this exposed or working portion of blade restricted. The unused part of the blade is guarded here, so safety again. Also, by restricting the length of blade between the guides, I restrict how much it can wiggle around, fancy engineering terms, and get a straighter cut. So let's rip off a few here. So I'm going to take what I just did, stack it up. Let's see if that's going to stay. That might try to push back. Let's see if it stays. I'm gonna take this cut speed kind of slow since the upper deck, second story of what I just cut is not well supported here. Let me see if it's gonna stay. Yep. Lovely. Do it again. Lovely. And let's see if I can do this one more time. I'm starting to get a little greedy here. Yeah, that looks stupid, doesn't it? I also have to raise my guide post. The guide post adjustment mechanism on this saw is kind of high, partially because this machine is taller than an average 236. I I can reach it, but I'm 6'4". We do offer as an option a powered mechanism to raise and lower that guide post. Maybe I should have pitched to these people. Now, this looks just stupid here. This looks stupid. I don't know that this is going to work. So I'm going to break the rules, and I'm going to hold the workpiece as I make the cut. Don't do this. I just want to see if I can cut through this much material. Make it a little less crooked. I'm going to use the laser. So I got the laser on now. I also, in addition to being a workpiece positioning aid, I call the laser a safety feature. The short version being, if you see the laser on your hand, move your hand before you make the cut. Since I'm going to have my hand, unfortunately, near the blade making this cut, again, don't do this. Having the laser, showing what's going on, I can go home with all my fingers. This is stupid. But sometimes stupid works. Let's see if I can bring this over to you. So it looks like, using the right blade, I'll have no trouble at all cutting through 3 foot of this material. My ultimate potential customer who wants to cut this material needs to cut through 4 foot, but I don't see any limitation. We're gonna do just fine. I'm very happy to find that this material, PET foam, can cut pine with a bandsaw if I'm using the right blade. The issue of softening or melting didn't seem to bother me here at all. I don't know what happened. Here's another view of this is what I received. That looks like it has some melting in it. So I don't know how they cut this before I got it, but there definitely was some melting and bad things going on there. They just need one of my bandsaws. So I appreciate your time. If you have any questions about the machine, the Model 236 Heavy, or cutting this PET foam or other materials, please feel free to call or email us here at Forrest Manufacturing. Thank you for your time.